This lesson is going to review our chapter on bonding, and as we get started, we want to talk about the differences between ionic and covalent. So let's start with ionic bonds. These are going to happen because of a transfer of electrons. And just as a reminder, it usually happens between a metal and a nonmetal. It doesn't have to be. If you have two polyatomic ions, those are both nonmetals, but if they're charged particles, so if you have a positive polyatomic ion and a negative polyatomic ion, those can also be considered ionic. But most of the ionic compounds we talk about in this class are a metal to a nonmetal. And the definition for this is the attraction between a positive and negative. So you just have to have ions, you don't necessarily have to have a particular type of element. In general, we're going to have metals, like I said, that lose electrons to become positive, and the nonmetals are going to gain electrons and they're going to become negative. The smallest unit for this is not actually a unit. It's called a formula unit, and it's actually a ratio. So it's a ratio of ions. So for example, when we talk about sodium chloride, it doesn't mean that we have one sodium and one chlorine. What we mean is that it's a 1-to-1 ratio between the sodium and the chlorine. And then a few more things. These tend to have higher melting points and boiling points than covalent. So higher melting point and boiling points. And they are able to conduct, but there's some conditions. So if they're either melted or dissolved. So they have to have those ions flow, and so they either need to be dissolved in something or they need to be melted. For covalent, these are going to be compounds that are sharing electrons. These tend to be all nonmetals. The smallest unit is called a molecule, and that actually is a unit. And that can exist independently. So a molecule like water is an actual little unit of 2 hydrogens and 1 oxygen that are stuck together and that kind of float around together. These do not conduct well, so we'll say they are poor conductors. They have lower melting points and boiling points. And there are 7 of them that will always bond to themselves. So you need to be familiar with these 7. If they're by themselves, you need to put a 2 on them. Those are called the diatomic elements. All right, the next thing we're going to talk about is the VSEPR theory. Actually looks more like VSEPR. This stands for valence, shell, electron, pair, repulsion. And this is the idea that all atoms have that negative electron cloud around them, and so outside elements or outside atoms on a molecule are going to push away from each other. And there are several shapes and bond angles that you need to be familiar with. If you have 2 atoms next to each other, or if you have 2 atoms on the outside but no dots on the central atom, that is called a linear shape, and the bond angle is 180 degrees, just like a straight line. If you have 3 outside atoms, the prefix for 3 is tri, so we're going to call this a trigonal, but then they're flat on the table, so trigonal planar. Plane like in geometry when you talk about planes. And so a third of a circle is 120 degrees. And then if you have 4 outside atoms, the prefix in chemistry for 4 is tetra, like the video game Tetris. And it looks kind of like a pyramid with one sticking up. This is called a tetrahedral. And the bond angle for this is 109.5 degrees, which is why it does not make kind of a crisscross shape, because that would be 90 degrees. You can also replace some of those atoms with electron clouds. So if we replace that top atom with an electron cloud, the electrons still repel those other 3 atoms, so it pushes them down, And so we're going to call it a trigonal because we have 3 outside atoms, but now it's a pyramid because those dots on the central atom are pushing the other ones away. And then the last one is if we replace 2 of those atoms with electron clouds. So now we have 2 pairs of clouds. This is what water looks like. And so it's going to bend those 2 atoms down, and that's what we call it. We call this bent. And these 2 are similar to tetrahedrals bond angles, but those electron clouds are pushing just a little bit harder than if it was an atom, so it squeezes them just a little bit smaller. So we'll call it less than 109.5 degrees. This one is actually 107, and this is 104.5. But for this class, all you need to know is that they're just slightly less than 109.5. The next thing we need to talk about is polarity. So if something is polar, that means that it is an uneven sharing or an uneven distribution of electrons. So the electrons are not sharing, or the atoms are not sharing the electrons evenly, and what that means is that you end up with kind of a lopsided charge, so that half of the molecule is more negative than the other side. And there are 2 things that can make it polar for this class. If you have extra electrons on the central atom. We don't get into the big complicated shapes like other advanced chemistry classes, so anytime in this class that you have extra electrons on the central atom, it makes it polar. And then the other thing that can make it polar is if you have different elements on the outside. Because those elements will pull differently, they're going to make it kind of lopsided. Nonpolar is an even sharing of electrons. And to be nonpolar, you have to have no electrons on central atom and both of these have to be met. You have to have the same elements on the outside. All right, and the last thing for today is intermolecular forces. The prefix inter means between. So these are forces of attraction that happen between molecules. So they're not as strong as bonds, they're not holding the molecules together. It's just if you have one molecule next to another, they can be attracted to each other. So we're not talking about within the molecule anymore, we're talking about between them. There are 3 types that you need to know for this class. The first is dipole-dipole. So di means 2, so we're talking about 2 poles, a positive and a negative. And this is going to happen between 2 polar molecules. So if one is slightly negative and slightly positive and another one is slightly negative and positive, they'll flip themselves so that the opposites are near each other. The next one is called dispersion. It's actually called London dispersion, but we just kind of shorted to dispersion for this class. This is between 2 nonpolars. And you might think that 2 nonpolar molecules would never be attracted because they don't have charges, but what happens is the electrons can get lopsided just because they're always moving, so they just might happen to get lopsided for a split second. And that creates a polarity, which then creates a polarity in the next one, and so they can be slightly attracted to each other. It's the weakest of all of them, though. And then the last one is hydrogen bonding. Sounds like a bond, but it's actually an intermolecular force. This is a special type of intermolecular force. It's actually an extreme dipole, and it happens between hydrogen of one molecule and either nitrogen, oxygen, or fluorine of a different molecule. So nitrogen, oxygen, and fluorine are the 3 most electronegative elements, and so they're going to become the most negative of the slight negatives, which will make hydrogen most positive of the slight positives, and so you get kind of an extreme dipole. So what you need to know is, first of all, you need to be able to recognize which type of intermolecular force something will have. You also need to know that this is the strongest of the 3, and this is the weakest of the 3. And you need to know that the stronger the intermolecular forces, the higher the melting points and boiling points. So I might ask you, which of the following compounds has the highest boiling point? What I'm really asking you is which one has the strongest intermolecular forces. So if you can identify, like maybe one of them has hydrogen bonding and the rest of them don't, that will tell you which one has the highest boiling point. And that's it for today.